Alright, cool. Now we're recording. Oh, right. Yes, I can. There we go. Okay, cool. And I'll turn my screencast keys on. There we go. Alright, so quickly, I'm just going to start off. You guys can follow along with this if you want to, but you don't have to. I've just kind of recreated some of the shapes here, and I'm just going to go a bit more into actually using them. So Gavin kind of mentioned having these shapes in your geometry for rigging topology. This first one, you have these three bands, and anytime you have a bend, so anytime your mesh is bending, you're going to want at least three bands surrounding it so that it doesn't deform too crazily. So you can use Control Tab if you're on an armature to switch in between object mode and pose mode really quickly. So that's just a little tip there. Now if I rotate this bone, you can see it does some funny stuff, especially when you close it up tight. A lot of pinching going on. Don't have this file at the moment. I'm going to go over the basic stuff. You guys can follow along if you want, and then I'll put the file up with some less basic stuff when we start that part. It should be really soon. We're not going to have too long of a tutorial today because, like I said, I don't want to step on Gavin's toes. But yeah. So you guys are all familiar with like setting up the armature, getting the bones, extruding them, setting them up. Generally, the tools for using the bones are really similar to the regular editing mode tools. So you can extrude with E. Yeah, they are pretty simple. That's why this is going to be a short tutorial. Uh, a few quick ones, I guess. If you have a bone like this and you want to separate it, what you do is you Alt P to clear the parent, and you can either disconnect the bone so that it's parented still, or you can clear the parent so it's just totally disconnected. There are going to be uses for that, not many, but it will come up eventually, so that's something you should know. And then to reattach, you have to use the selection cursor. So if I select this thing, I can hit Control S, cursor to selected, select the end of my other bone, selection to cursor, and then I have to parent it and hit connected. And then it'll turn them back into one bone. So you can't use M to merge like you can with editing tools, but you can do it that way. Figure out how to attach armatures to a mesh. Cool. So let's do that. Why don't I just rebuild these? We'll start with, whoop, there we go. We'll start with this one here, just to really quickly get you something going. And if you just follow along with this part and you haven't done your in-class activity yet, if you just have this, like a moving bone inside this object, and then you pose it, you can post that for your submission for tonight. What would be the use of keeping the parent but disconnected? Good question. We will get into that. It's going to be IK stuff, which I'm going to touch on a little bit. I think Gavin's going to go over it next week, but we'll touch on it anyway, just for fun. It's really interesting stuff. It's not too hard. It's not like, you know, if you guys are in Hoag's class right now, then you guys are probably doing fabric, and you're probably doing IK by hand, and it's nothing like that, I can assure you. It's much easier. Hoag's class? Oh, is it not Hoag? Oh, who teaches you, oh, you have Samantha. Right. But that's still good. I don't know Samantha. I've never talked to Samantha, actually. but I'm sure she's good. I've heard good things about her. Mm. Oh yeah, this has probably been mentioned to you guys a bunch of times, but she used to do this thing with Pegman where they had like meme awards, and the class would create memes, and then Samantha and Pegman would review them and give bonus marks for the winning memes. SpiceCon, yeah, that's what it was called. So you guys have heard of it. SpiceCon's great. Anyway, Samantha's probably also teaching you Fabric by hand, so you still don't escape Fabric, but having Hogue twice was great, I will say. Not yet? You haven't started Fabric yet? You probably will. Oh, you did? Okay. Briefly. It's a big thing. There's a lot going on with Fabric. It will be on your final exam, I guarantee it. It's like this one big equation, and you just have to plug it in and do it recursively over and over and over and over and over, forwards and backwards. Yeah, so Fabric is forwards and backwards inverse kinematics. That's what it stands for. It's the whole thing, but that's not for this class. It's just cool. For this class, though, I'm going to start by adding a cube and moving them on up. And I'll just make it the same height as the other ones. So to add an armature to our cube here, I'm going to Shift A and go down to armature, and it's single bone. I've got some other things here. That's part of an add-on called Rigify. So if you want to download that, but these are basic armatures that are used as guides to create more complicated armatures. And you won't be allowed to use them for your assignments and stuff, so I'd recommend sticking around and just learning how to use the bones normally anyway. But we'll start by using G, just like normal, and Z to drag the bone around. Drag it about to the halfway point, or I can snap it to the same height as this one, and drag the second part out. So everyone's good with that, right? View of just the armature. I'm going to wireframe mode. So it's really person dependent. Gavin likes to turn on in front. So armature, viewport, display in front. So it always shows up in front. Personally, I'm not a huge fan of that, but to each their own. This way, if you click it, you can click it through other objects. What I like to do is I'll leave bones that I want to edit, leave the ends out, so I can click the end of the bone. Especially on the fingers, that's a good way to control them. Although Gavin did show you how to change control meshes and like make your own custom controllers, and that's definitely better. I'll show you a file with that kind of stuff going on later, after I show you the other stuff. Yeah, the custom shapes are cool and super useful. The way that generally we go about doing armatures is you're not thinking about yourself using it, but you're thinking about your animator using it. Because in Ubisoft, for example, they have tech artists who are doing the rigging. So the actual artists themselves will do the sculpting, maybe the retopo, probably won't even do the texturing. Then it'll be passed off to somebody for texturing, and it'll be passed off to somebody else for rigging, and then passed off again for someone to animate. Right, exactly. So those what's it called? Those custom shapes, they let you know what each bone does without you having to just move it around to figure it out. And there are standards involved in that so that people can tell, like animators in the industry, there are certain bone shape standards so that you can tell exactly what they do. But we won't get into that too much. But yeah, same principle as when you're building your engines. You're not thinking about, just building it for right now. You're thinking about building it with a use case in mind. So that's why we use the custom shapes and stuff like that. So if everybody's got this, then I'm going to go ahead and parent. So I select the armature second, select my cube, select the armature, and then Control P. So it shows up in the bottom left. Control P, and we're going to select with automatic weights. Boom. And you'll notice now that my cube, if I go to my vertex information, whoops, my cube now has bone and bone 001 vertex groups. And if I go into weight paint, I can see the influence of those groups. For the activity, they don't need to be complex at all. So like I said, if you just have this box and it's spun around somehow, it just needs proof that you can take an armature, attach it to an object, and move part of it. So really simple. I'll probably animate a door at the end of this if you want to submit something a little bit different for your submission instead of this cube. Because then that way I can also just sort of touch on animation stuff. Because I was looking at the submissions and it looked like a lot of you dived in animation a little bit. So a little bit of an early crash course, I guess, just really briefly. Because there was one thing I saw that that really caught my attention about using Maya before using Blender, and then how the animation program's different. Dabble in animation. Yeah, so I'll give you guys a little bit more of a, yeah, that's exactly what I wanted to talk about, is using graphs. Blender uses their, I don't even know what it's called, to be honest. It's like their animation sequence editor, dope sheet. It's called a dope sheet. That's what Blender typically uses. But there are graphs in Blender. That's what I use. I use graphs in Blender when I animate because they do work better, and it's just a better workflow. But yeah, so you don't have to do frame by frame animation. So one big thing about 3D is that you don't have to do frame by frame all the time, and that speeds it up a bunch. Anyway, whole bunch of tangents, but let's get back to our cube here. So if you followed along with that, you should have your armature and your cube, and if I go into pose mode on my armature, it should move the cube. And I've left this cube without any ring, so you can see what happens. These vertices are being attached to this bone, and these vertices are being attached to this bone. It tries to bend the mesh. So whenever you're using bones, what it's doing is it's bending the mesh. It's deforming. It'll never add new geometry. It'll never remove geometry. It just changes the existing geometry. And the more loops we have, of course, the more geometry we have, then the better it's going to bend. Because there's more geometry. It's like if this wanted to be a curve with 5 points, it couldn't do it too well. But if this wanted to be a curve with as many points as it has now, it's a lot cleaner of a curve. Of course, this is not the solution to having topology problems and bending problems. Non-destructive, yeah, it's non-destructive, so it's never going to affect your mesh in any way. And if you delete the armature, so if I move this around, go back into object mode and delete the armature, it'll snap back to its original position. Loop cuts are looking great. Yeah, no, you don't want to do this. You want to have minimal geometry as often as possible. So that's where these come in. So if I add a single loop cut now, and I'm going to reparent it, just that it gives new vertex weights. Control tab. Now it bends slightly better. Yes and no. So that's kind of, I guess I can get into that, but what you guys are going to be doing for your engines most likely is lerping between a series of static poses. So in each OBJ file, you'll have a string of OBJ files. Like you'll have just a whole bunch of them, like animation frame 1 all the way to animation frame 60, and you'll load in every single mesh as its own mesh, and then your object will lerp between each of those poses. That's typically how it's done. Yeah, morph targets. That's typically how it's done. If you're wild, you can try and implement skeletal animation, which is where you import the bones and their weights as well as the mesh and render it all. Um, it's a massive challenge. Two groups, yeah, two groups in my year had working skeletal animation by the end. Um, and one of the groups, which was my group, had it not actually like it was breaking still at the end. So our final project actually still has broken IK or skeletal animation, but it's really difficult. If you do really want to look into it though, do you guys have Dan for GDW as a TA? Yeah. So Dan worked heavily with our year last year on getting skeletal animation in. There was this whole thing. Gavin made a Trello board and stuff like just for the entire class to contribute because he really wanted to get us sorted out with skeletal. So if you talk to Dan, he probably still has resources about that kind of stuff. If you really want to get into implementing skeletal animations, it makes the animations look much better because you can implement the graph functions into your engine, which I'll talk about when I get into the animation side of things. But then for now, I guess we'll just continue with this really quickly. I'll just explain why we do 3 rings. So if I do 1 ring there, you can see how it bends kind of weird because it's these aren't moving. The 4 vertices in the middle, they can't move. If I add 1 more here, oh, your loop cuts don't show up when I switch to pose mode. How do I make them show? When you switch to pose mode, you should be in pose mode on the armature itself. So I'm rendering the wireframes out on top of everything right now. You won't actually see them. Yours will look like this. I'm just rendering them out so I can give you guys a better visualization. Yeah, but they are there. And if you want to know how to turn on wireframe, it's one of the overlays. Anyway. So with 2 bones, you see it gets slightly better because now I'm pointing at my screen. The bottom vertices are allowed to stay where they are, and then the ones above are allowed to move around a little bit. Generally, what we want is 3 loops, and if you have 3 loops, you have decent enough movement. Really, what you want is to have a particular topology for every type of bend, so that's where these come in, and I'll get into those just after. But for now, what you can do is just add that 3 loops. So around your, I don't know if you guys can see that. I don't know if it's in camera, but like around your elbow, you'd have a loop running exactly at the point of your elbow, and then 1 on either side for every bend. So 3 on the wrist as well. The fingers are a little bit different, but we'll get into that in like a couple weeks probably. But now if I have 3 loops, and I'll just reparent it to get new weights. It bends much more believably. So generally 3 loops is what you go with. It's a little bit off because it didn't give me new weights, which is actually something you run into a lot. So if it doesn't give you new weights and it's acting really weird, like it was for me just now, where it's keeping this line straight instead of bending, what you do is you go to the object, so in this case my cube, and I'm just going to come over to vertex groups and delete them. If you have a whole bunch of bones, you just have to sit there and delete all of them one by one. There's no way to mass delete them, unfortunately. Oh, actually there is now. That's new. There never used to be, but you can. Look at that. Now you can just come here and hit delete all groups. So, and then reparent, and that'll give you new weights. And now if I move it, it shouldn't have those problems. Yeah, still kind of is. But you get the idea. Just go in object mode and get rid of that. So to fix that problem, Gavin showed you this mesh in the middle here with the single face and then the double face. And that way, if I rotate this, the back doesn't pinch in. And like he mentioned in the tutorial or in the class as well, this only works for joints that bend one way. So if this bent the other way, you're going to get that weird pinching and this part's going to not bend properly. But if you bend this way, it's fine. Another thing about pose mode is that your basic tweak functions, so all of your edit mode tools, or not all of them, but important ones still work. For example, if I want to get this back to its original position, because your armature, when you set it up and add it to the mesh, it will give it a base position. If I hit Alt-R, it'll clear my rotation. So if I spin it like that, I can hit Alt-R, my screencast keys just disappear. See, it's not me, they just do that. Alt-R will clear my rotation. I can't move these bones in this case, because there's only two of them, and they're attached together. But if I were to move one and hit Alt-G, it would move it back. I can show you that on a different one, a different mesh. Looks like a plastic straw. Hopefully this one will look more like a plastic straw. So if you're looking at this, you're probably thinking, it doesn't really look like an elbow, with it being a cube and all. But you can apply the same principle to a rounded object as well. So here I've got an octagon. It's 8 sides, which is probably what you guys are going to be wanting to work with for your characters, is 8 sides for an arm. Because roughly that's just an easy low poly character. And here you'll notice I've actually got my bones not straight up and down. I've got them tilted a little bit. And since this is going to bend only one way, it's better if you give it just a little bit of an angle for things like constraints later on. So you have to kind of know which way your bones are going to go. I'll talk about it a bit later when I get onto building actual rigs. But for now, just know that, yeah, if this is a knee, for example, I'd want this part to bend where the knee would bend. So this is the inside of the knee. But you can use that same pattern. So I've got the triangle and then the back faces combined to a single face in the front, or a single edge. And it has the same effect, it's just this time it's on a cylinder. So you can use that for arms, knees, legs, things like that. Alright. So is everybody good with that stuff? Just a review of what we've done in class. So. If you do still have questions about this stuff, now is probably the best time to ask before we get into more advanced stuff, because if you need help with this now, you might get lost pretty quickly. It shouldn't take too long though. Oh, actually. Oh, right, I had to restart my computer. Hold on. How do I do the diagonal? Oh, right, that's true. Gavin really didn't go into that. So I'll just take this one and make it look like this one. So what he's done here, if I just make this closer, he's grabbed these vertices at the back and used an edge slide. So if I hit G twice, I can do an edge slide, and it lets my vertices move along whatever edge they're attached to. You can also slide an entire edge along its perimeter edges, like so. It'll take other geometry with it. So if I take these back edges and slide them up, now I've got my top half of my triangle, and I can just use J to connect the other parts. And then when I'm done, I can merge everything by distance and get rid of those extra vertices, and now I've got a proper shape. You can't use F for that, Jonathan. Can I repeat that? Yeah, sure. So when I select the back edge here, or whatever edge is going to be bending inwards, I can slide it up and down by hitting GG. So if I hit G once, it brings up the regular grab and move. If I hit G twice, it brings up edge slide. So I can slide it up or slide it down, doesn't matter. Merge them in with everything else, so now it's solid. And I'll show you why you can't use F here. So if I hit F, if I click this face, you'll notice that it's still selecting these 4 points. That's because when I hit F, it makes this new edge that's not actually attached to anything. So you can see it there. It's just floating between these 2 points, but it doesn't actually do anything. But if I hit J, then this edge is attached to the face. So if I hit this, now you can see it's separating them. I come around the back and hit J again. Whoops. It's being finicky. It's not necessarily an alternative way to... What is going on? There we go. It's not necessarily an alternative way to loop cut, because in this case, a loop cut wouldn't do anything for you. But it is kind of an alternative. If you're using the knife tool to just do single interactions like that, you should be using J instead, because it's just faster. So the extra edge benefit with the actual deformation of the shape. Just like I was saying here, if I don't have them, come on, let me do stuff. There we go. If I don't have these, this is another shape, by the way, that you can use. It's just the same thing, but a little bit longer. But if I get rid of all of these, oh, what's going on? And then rotate this. You'll notice how it deforms all funny. So those extra loop cuts are to help it deform more closely to your shape. I guess an easy way to demonstrate that would be if wow, it really does not like doing what I want it to today. If I make a cylinder, I just drag it over here and drag it up. If I wanted to have one loop cut like this, and I want this face to be here, I'm going to get a straight line. But if I want a curve that goes like this, then I'm going to need a bunch of loop cuts in here so that I can get that curve. Oh, to make that extra line so quickly, yeah, it's just using J. So J creates a line between 2 points. It splits the face. So I have one face here. If I use J, now it's 2 faces. And to merge at the end, I'm just selecting everything and hitting M and then merging by distance. Yeah, that's a good way to put it. F makes a face that's not attached to existing topology. That's technically a face, but it's like a 2-dimensional face. So it doesn't really help anybody. Turning on auto merge also works. Yeah. That would prevent you, if you have auto merge on, you would just slide them up and it would merge automatically. Yep. So hopefully that clears that up. And we'll jump into something a little bit more exciting, I suppose, something that will be new to you guys. So I'm going to go grab my file now. I had it copied, but when I crashed, I forgot it uncopied. How do I get out of here? There we go. So if you download that file, it's a really small file. It shouldn't take very long. It's going to look a little bit different from mine. You've probably got, I'll get rid of this. There we go. And you'll have this stuff here. So I'll give you guys a minute to just get that sorted out. This stuff is technically a little bit more advanced, so like I said, you might cover it next week. It wasn't exactly clear what you guys are doing, so just thought I'd show you. Looks like a swole leg. Yeah, this is my shoddy attempt at making an arm extremely quickly. I mean, it's awful, but it's just something to show you guys how it would work with the topology and everything. This is a hand. I just did not feel like modeling a hand, so I just made the rig separate. So I've included all the shapes in there. You don't need to have the other three, I guess. You've probably seen those before. They're just there for reference. I'm going to show you guys how to build these. And then after that, I'll show you these being used in other armatures I've made. Not quite as advanced as Gavin said he showed you in class, but to give you an idea of what I did in second year and what you guys could maybe do in second year. Yeah, I mean, we'll just call it's an arm. But I guess I'll go over it really quickly so I can show you guys what we're going to have when we're done following along. I've got an arm set up with IK, so you can use IK to, I have vertex snapping on, it's freaking out. You can use IK to move the body around. In this case, the arm goes towards the hand with pull targets, so you can change the direction of the elbow. And then you can make really quick poses with whatever you're working on. So something like that. So that'll show you guys how to use IK really quickly. And just select everything, Alt G, Alt R. And then this hand, I'll show you guys how to use constraints. So that you can have a hand that, like in this case, closes itself. And hopefully we can do this in under an hour, and you guys will have roughly an hour to finish up your in-class or just go eat before your next class, because like I said, there's not too much we can go over without diving into more advanced rigging stuff. The basics are exactly that, super basic. So does everybody have this downloaded now though and ready to go? I know JJ does, I can see it. Yep, yeah. Oh, also, oh, my Discord closed right because it crashed. Did you guys say anything? Okay, cool. We are good. Didn't miss anything. Cool. So I'll start with the hand because that'll probably ease us in a bit. Constraints are a bit simpler to understand than IK. So move this over. And let's make a new armature. And hop in edit mode. All right. So really quick, since somebody was asking about it, and this is a good example of when it's used. I want this bone to be the beginning of my finger bone, so I want it to be this one here. That'd be the proximal phalange, I believe. And knowing the bones' names might come in handy. You don't need to name your bones after human bones per se, but for reasons that we'll get into later, and that Gavin will go over a whole bunch in the coming weeks, Nate, you have to name your bones properly. You created a new armature, but I don't have any bone. Single bone? It should make up just a bone. Are you in edit mode? No, that wouldn't work. If you're in edit mode, it would just add a new bone. Taylor? Just leave that for now then. But to start, I'm gonna use Alt P, like we were talking about. Your origin is out of place. Okay, cool. So I'm gonna use Alt P, and I'm gonna disconnect the bone, but I don't want to clear the parent. Because if you can imagine this is a hand, right? I want my hand, so if this is my hand bone, I want my hand bone to control my finger bones. So I'm going to select the connected bone, Alt P, and disconnect, but keep the parent. And you should have this line drawing them between each other. That lets you know that it's still parented. And you can move it off. All right. And now I'm going to come down to the bone properties tab, and I'm going to name these. How? Yeah. Alt P. So if I click this bone, you can see they're connected right now. If I hit Alt P, I can disconnect it. So disconnect. I wonder if this will just work again. No. There we go. Cool. Weird. Alright, this time with screen keys. Alt P. Disconnect. There are also cases where you want to clear the parent entirely. When we do the IK stuff, a couple situations will come up like that. But for now, we should have a hand bone. So let's go to the bone tab here, the bone properties tab. And right now it's just called bone, so I'm just going to call it hand underscore L. So it's the left hand. And then how I like to do fingers, everybody's different. You'll find something that works for you. For fingers, I just do it based on the name of the finger. So in this case, it would be pinky underscore L. And then when I extrude it, so if I extrude it up again, pinky L01 and pinky L002. So pinky L1, pinky L02. All right, cool. So everybody has this. Or something like this. Or do you need me to go over something again? Anyone? Good. Cool. Is anyone stuck behind and need me to go over something? I should probably take that as a no and just keep going. Okay. So we have our bones and we have them named. Now is the interesting part. So I'm going to bring these a little bit closer. I'm going to click on this farthest bone, and I'm going to go to this little meat. Kind of looks like a slice of ham or something. This one right here. Wait, that's not right. Hold on. I'm in the wrong mode. You have to be in pose mode. So go into pose mode. And then there it is, the meat looking thing. Yeah, no, I thought it looked more like meat. I was wondering, it was the wrong tab, that's why. Yeah, this meat looking thing. And what this is it's called the, yeah, JJ posted it in the chat, thanks. It's called the bone constraint tab. And if you add a bone constraint, there are a whole bunch of constraints, and they're kind of like modifiers for bones. They let you do different things. So you can copy rotation, location, scales, whole transforms. You can limit their transformations. You can add inverse kinematics and different types of inverse kinematics. There is a whole bunch of stuff. But for now, I'm going to go ahead and add a copy rotation. So now you see my bones turned green, and that means that there's a constraint in place. So in this case, with the hand, I'm going to be rotating it on the x-axis. So I'm just going to select the x here. For my target, I'm going to select the next bone. So I want to copy this bone's rotation. So because I named them, this one's pinky 2, this one's pinky 1, this one's pinky. Pinky 2 will copy pinky 1. I'm going to add that same constraint to the next bone. So copy rotation, x, and then this one's going to copy pinky. So pinky 2 copies pinky 1 copies pinky. If you rotate now, nothing's going to happen. But if we go here, we can set our target to local space and our owner to local space. And we'll do that for both constraints. And now if I rotate on X, you'll see that the other two bones are copying this rotation. So some of you are playing around with using individual origins, I saw, for your submissions, where you had a worm that would, like, well, pretty much just do this. Exactly. Except without actually having the bones do it, just by doing it per origin. This way, you can do it without having to affect each origin. Yeah, local space on both target and donor. And now, I'm just going to copy this a bunch of times. So we'll go back to edit mode, copy, copy, copy. And we'll just make it more hand-like. So I'll make that one smaller, make this one a bit smaller. There we go. Not moving correctly. Are you rotating on the x-axis? So if I go into pose mode here, they're only on the x. So x, local space, and make sure that they're copying the bone before them. So you might have done it backwards, where this bone's going to copy this bone. That works? Okay, yeah, cool. So once it's on the x-axis, you'll have to like play around with the axis, because when you make the bones on your actual armature, they might not be on the x-axis. In this case, though, they are. So that's why I've done it this way. So I can rotate the whole hand, or I can rotate just the finger. Just for now, it's not a huge deal, so I'm just gonna probably leave the names. This one will be Pinky. Yeah, this one's Pinky 3. Maybe rename them. So we'll call this one Index L. This one will be Index L also. And this one will be index L also. And if you just type in the same name, it'll automatically add the 001, 002. And then we have the middle L. And adding the L is really important for reasons I will explain shortly. So middle L01. And this part's kind of boring, but super necessary. Pointer L. But you'll notice that now the rotations are all not going to work once you change names. At least I don't think they do. Or maybe they still do. Hold on. Oh, they totally still do. Cool. And now we have a hand that sort of grabs. Now, if I hit X twice, you'll notice that I can get a whole bunch of these to come up, and this is probably better. So if I rotate, I can rotate all of them. If I rotate on X, I rotate from the central X axis. But if I rotate and then hit X twice, it'll do it from all their individual origins. And right now it's not doing anything, but I'm going to introduce you to something called roll. And when we introduce roll, it will start doing stuff. So if I go back into edit mode, so right now all of our bones, since we made them in orthographic view, are pointing straight flat at the camera, like this. So there's no rotation like this. And we can't, as humans, really do this with our fingers, so I'll use my arm to demonstrate. But I don't know if you can even see me. If this is the bone, and this is the flat face that's facing towards us right now, if I rotate around this one axis, it's going to go straight. But we have the ability to introduce roll. So if I turn my wrist a little bit in this case, you can't see me in presentation mode. I'm still in my webcam. I just kind of, it's there both. If you look for my webcam, you should be able to see me kind of small. I just full screen it for a second, I guess. And I should be in like the top left, top right corner, one of the corners. It's a brief explanation, but it's also hard to see. I'm wearing a dark sweater. Ugh, all right. So if this is my arm, and this is the front face of the bone, as like this bone, it's front facing. I can bend my arm on that one axis that we specified. So this is me bending my arm on the x-axis, right? And it's going straight down. But what we can do in Blender is introduce roll. So instead of having this straight towards the camera, I will roll it like this. And it'll bend that way. Or like this and bend that way. And where this comes in is if you look at your hand, your fingers, they're not all going to be flat. They're kind of pointing inwards a little bit towards the center. So if you close your hand, your fingers don't go straight down. Like if I have my fingers up like this, when I close them, there's no gaps in between my fingers. You can't do that because your fingers are all rolled inward slightly. So now, if I go back here, you notice when I rotate these, that they're flat. So it's not, they haven't closed in on each other. They're just coming down straight on that axis. So let's introduce some roll. That's not what I want. Come on. There you go. Let's introduce some roll so that they start to close in. I'm going to go into edit mode here and come down to the bone tab. And it's in the properties menu. So my bone tab, properties, roll. And I can adjust this. So I want them to bend slightly inwards. So, and for these pinky bones, I'm going to introduce -7 roll. You can't just play around with it. I just know -7 works reasonably well anyway. So I'm gonna make all of my pinky bones -7 roll. And you make sure you do it to all the bones on the finger. These two you don't really have to change much at all. So for this one we'll do like -1, -1, -1. As far as I know, there's no way to batch edit them, so you have to do it for each bone individually. Roll 1, roll 1, roll 1. And for these, I'm going to do 8. I think 8.5 is the accurate one, but I'm not entirely sure. 8, 8, 8. And if you look here, now you'll see they're not flat. These ones with 8 degrees, you can see the other side. You can see that they're no longer flat, and they're pointing slightly inwards. And now, if I rotate on X, they're still separated. But if I rotate on X and their origins, they'll start to come together. It didn't really, they need more values, but that is why we use that. Let's increase these. I'll just exaggerate them. 22, 21, 21, 14, 15, 14. I might have made the armature a different size, and that's why the same values don't work. Let's rotate this one now. There we go. You can see they're closing together. It looks like I actually had the values for these two backwards, though. So just swap that. So let's increase these a little bit more. So this, in terms of making rigs, there you go. I mean, you get the idea. I could sit here and tweak around until the numbers are all perfect, but I think we'd rather just move on. But yeah, so that's how you could do what's called a grab, I guess. Something interesting you could do is add another bone and use that bone to control these bones. So let's do that now. This one won't be in the file, but just really quickly. If I make an extra bone here, separate it, clear the parent, put it over here somewhere. I'm going to give these bones a new constraint to copy the rotation of this bone. So let's call this one grab L. Select these bones. If you want to just copy that onto all these other bones, select all these bones, then select this bone last, and there's no ability to link, like you can't hit Control L, but you can hit spacebar and type in copy, and you can copy constraints to selected bones. So now they all have it. Alright. And now let's go in here and set our target. I probably should have done this first before I copied it, because now I'm going to have to do it individually anyway. I'll set to grab L, and then local space, local space. I'm just going to copy it over to the last two. And now I can use this to just control the entire grab. It's the same constraint, copy rotation, but this time I've mapped all of these bones rotation to this one. So I can rotate just this one and have the same effect as rotating all of these ones. So sometimes you'll see this one. This one will be like a diamond shape for the custom mesh, and it'll be placed usually by default in like the palm of the hand, and you can control grabbing with it usually. So that's some really simple use of constraints. It's the same armature. So I just grabbed this bone, extruded it, removed the parent. So extrude, then Alt P, clear parent, and now it's its own bone. Alternatively, you can just click your 3D cursor and hit Control A, or sorry, Shift A. It'll add a new bone. But no matter where this bone is now, it's attached rotationally to these. So it doesn't matter where it is, because it's not parented. The benefit of doing this, there's a couple things. One is you could turn this into, you could add a control constraint. So for example, this is great and all. Whoops. How do I do it? There we go. Pose one. This is great and all. It's not doing anything. Alright, it stopped working on me. But oh, it's because I hit Control Z too many times. But when these are locked to a constraint, like a working constraint, I can no longer move this, like I can't rotate this bone by itself anymore. And the benefit of separating it is I can have it work on this grab and have a separate constraint that allows me to move each individual finger on its own anyway. That's a bit more complicated though, and would take a lot more time than today. So for now, yeah, you can do something like this to just get a simple grabbing, just to make it more convenient for animators, or you can grab the fingers. In the case of fingers, it's okay, I guess, because there's only 4 of them really, so you can just quickly grab all 4. But sometimes you'll be using these constraints to save yourself from having to click like 20 different bones at once. So hopefully that answers your question. It might become a bit more clear when I show you a full rig that actually uses some of these properties. But for now, yeah. So hopefully you guys have a pretty good understanding of this much at least. So that's how I made this hand over here. The only difference is I added the thumb, but it's the exact same principle. To get the bone to work with the unparented constraint, you should, whoops, make sure that your parent is set, or your target bone is set to the separate bone, and make sure that the separate bone is a part of the same armature. Yeah, bigger picture is hard with rigs. There's some really complicated stuff you can do, but there's also some really cool stuff you can do. There is a whole job in the industry dedicated to just rigging. So it gets pretty technically advanced, but it's usually a big part of being a technical animator, or sorry, a technical artist. So if it moves automatically, like it will do that, but then you just have to come in and make sure you set the world space to local. In high demand, I think it always is. Generally, technical artists in general are always in high demand because you don't find a lot of people who have both the art side of things and the programming side of things, because usually just if you have a very logical brain and you do a lot of technical stuff, generally art is not your strongest suit, and same way the other way. But like unpaid too, right? No, tech artists actually make good money. Not quite programmer level, but a lot higher than just standard 3D artist. It's not that they have no brain. I mean, don't get me wrong. I'm not going to go out here and trash on artists. I'm an artist. But it just generally, if, people say like left side, right side brain, and they clash. And like if you're very one side of the brain, don't remember which, you're very technical, and the other is very creative and artistic. And it is a different kind of brain, yeah. It's an entirely different skill set. So that's why technical artists are in such high demand, because if you can figure out both, then you are one in a crowd of many. Like you stand out. Balance. Yeah. You literally are a god, and people will do all kinds of things to get tech artists. Not so much the smaller indie studios, although even they have uses. Kanye West. Kanye West. I think Kanye, I don't know. I think his whole brain just stopped working. Not his left or his right side, just the whole thing, all at once. Kind of sad. In the words of Kanye himself, I miss the old Kanye. Anyway. Ugh. Yeah, so technical art. Very cool stuff. Um, so let's get on to making a whole arm. This will be fun, and it's going to take a little while. But like I said, I hope we will finish before 4. Give you guys an hour afterwards to do whatever. So let's move this to the side now. Oh, and for the thumb, if you're wondering, it's the same thing. It's just another constraint. So you can see it there. All right, so now we're going to do a quick introduction into inverse kinematics and the wonderful things that come with it. How did you make the outside armature the parent? I didn't. So this will only work if this is part of the same armature. So this is all part of the same armature. The bone is just separated. Like if I select it, you can see it's selecting everything. The bone itself is just not parented. It could be parented. It wouldn't really make... Whoa. It could be parented. Wouldn't really make too much of a difference if it was parented. Except for that... actually, I guess it wouldn't. It would just follow it around. But yeah, just make sure it's part of the same armature. I didn't even see that one. He outsources his thinking. Yeah, I don't know who he's outsourcing to, but he's outsourcing it to other Kanye that lives inside his mind. There's 2 of them. So for the... there we go. For the human rig, I'll also kind of get into practices and stuff. There is a species of Kanye. There's... I'm just going to leave it for now. I could get into it, but we got things to do. So for this human rig, there are a few things here. I haven't actually made the proper shapes for these, but I'll go over what generally is what you do. You start with a root bone. So you can see I've named them all too. So this one's named root. And every armature you make should start with a root bone. Usually it's placed at the bottom of the character and looks like a sort of like a control, like a circle with arrows coming out of it, like Gavin made in the class. And you need that root bone because you need to be able to control everything in the armature at once. In this case, it doesn't control these two because they're separate, because they're for IK. Torso at the waist, basically the waist swivel. No, like root bone controls everything. It should move the entire character all at once. Let me see. So this is that other rig. This was my 2nd year rig to give you an idea. It should be at the bottom. Yeah. I put mine at the top here because I didn't know at the time that it was supposed to go on the bottom. Ooh, that's not it. Okay, we'll just do it here. Pose mode. So this is the root. And you see it controls the entire skeleton. It should move everything. Everything should be connected to the root. Normally it's at the bottom, but in this case I have a lot of feet stuff going on, so I put it at the top, and like I said, I didn't know any better. So in my case it looks like a puppet controller. In most cases it looks like a circular game controller at the bottom of the feet. So that's what that is. And every armature we make should start with that, so that we have total control over the entire mesh's locomotion, and not just the rotation. Yeah, that's a good way to put it. It's the stand for your figurine. So in this case, I probably should have these parented. I didn't, but if this IK bone should be parented, keep offset, and this IK bone should be parented, keep offset, so that when I move the root bone, even the IK bones come with. Cool. No, because it's not in the torso, because you have actual bones in the torso. So in this case, like these ones. Like these bones in the torso control the torso. So these ones control the character's movement as well, the same way, but they still have the IKs. So in this case, if I want my character to bend down or whatever, or this bone in the torso controls the character's torso rotation. Same with this one. So usually it's at the top or at the bottom. Okay, cool. So let's get started with making this. I guess something we could do is just copy this over. So let's just duplicate this. Clear the parent. And let's make a new mesh or armature. So I make a new armature, single bone, and I would make this one my root bone. So before anything else, I'm just going to come on here and name it root. Okay. And now I'm kind of getting into stuff that is questionably part of this tutorial, and maybe I should leave it, but we're going to do it anyway. I'm going to add a new bone here, and then just clear it, bring it down here, parent it with the offset. So the reason I've got this floating bone here is because, like I said earlier, we're trying to, with human characters anyway, we probably want to mimic bones in the body. That's just an easy way to think about it. You'll have more bones in the armature than you do in the body, like the big ones anyway, but it gives you a general idea. So in this case, I've got the clavicle here. So I'm going to start with the clavicle, and bring it up, and bring it out, and then the clavicle is going to go to where the shoulder begins. I'm going to bring a bone down for the shoulder, and then I'm going to extrude it down again to my elbow. And this is another part that we hadn't mentioned yet, but you need to make sure that your bone lines up with your topology joint that you've made. So in this case, I've got it here. I need this to line up with that. At the moment, it's offset, but that's okay. Just leave it, and we can move it all later. So I'm going to drag this down again, extrude it to my wrist, make sure that the point of my bone is lined up with my wrist, and then extrude it one more time out the end of my finger, and I want this whole bit to be past the finger. Okay, so let's grab everything and move it more into place. There we go. Cool. So now we have to go in and name our bones. Again, this is super boring, I know, but definitely follow along with naming them this time. You'll see why at the end, but definitely name them with me. So clavicle, Yeah, this is the right side, so R. Yeah, shoulder R. We got the, of course, the bone's the humerus, but just for simplicity's sake, I'm going to call it upper arm R. Normally you've got your two bones in your forearm, but again, to simplify, I'm just going to call it forearm. Yes, I am going to do the RTL thing, so make sure that you follow along with the naming and make sure you include the R at the end. Very important. And then hand underscore R. So at the end of this, we can create essentially a mirror of our bones. But you only do that once the bones are 100% finished. And right now they're not because we still have to add our IK. But to play around with it, if we go back to our root bone here, I'm going to introduce you to something new. So on our bone property settings, there's a checkbox and it says deform. And by default, it's always checked on. But on our root bone, we don't want our root bone to create any vertex groups. So that's what it's doing. So if you have deform on, then when you parent with the automatic weights, it will grab bones and add them to its vertex group. But with deform off, you don't have to worry about that. If you have spacebar enabled to search, like I think most of you do, you can select both of these. In this case, the clavicle, we don't want it to affect any geometry either because there is none. It's just there for like completion's sake. So I'm gonna hit selection and I'm just gonna search deform and I can change the bone settings. So I can also do it with Shift W, but bone settings, I can come down here and you can see there's it's still written in the Blender Python code that they use, but it's still, you can change it. So toggle, so I can toggle deform on these bones. I can enable deform on these bones, see it checks it off, or I can disable. So I'm gonna choose disable, and now these bones both have deform checked off in both their properties at the same time. And now we'll parent with automatic weights. And just to see if things work, I'll go into pose mode and start moving things around, and you can see everything works. Cool. And you'll see when I move this bone that the mesh doesn't deform at all. So it's moving it, yeah, because it's moving these bones, but nothing that this bone ever does will affect the geometry. Same with the root bone. It can't affect the geometry. Only the other bones. And there are a lot of cases when you want deform turned off, and we'll have a few more right here. So let's go back into edit mode. I'll take a quick look. Speak configured joints called butterfly joint, shoulder, upper arm, forearm, and hand. Yeah, that works too. It's whatever naming system works for you. For whatever reason, particular bones, just their names work better. Particular bones, I just use the part of the body. It all just depends. The important part is that you make sure you have the underscore R. The R can be at the front, so you could have R underscore clavicle, and that would work too, but you just need to have some kind of R separated by a non-letter character, or like a non-alphanumeric character. So clavicle dot R or clavicle underscore R, anything like that. Rather the purpose than the real bones. I don't remember them all. Okay, yeah, that makes sense. If you don't remember the bones, then definitely don't try to name them by the bones because you'll not know what anything is. Just make sure you don't leave it as Bono 1, Bono 2, Bono 3, Bono 4 because you will eventually have like 100 and you'll never be able to find anything. Alright, so let's start doing IK. So hopefully everybody has something like this, right? Bono 1 question mark R. I think that should work. I'm pretty sure the only restriction is that it can't be alphanumeric. But I think you could theoretically Bono 1 exclamation mark, question mark, or anything like that. All right. So does everybody have this much of an arm? Yes, no? Is anybody stuck somewhere? Didn't do anything too crazy here, just made the arm and then parented it, named it. I'll take the silence as a yes, we're all good, and then I guess I'll start IK. So here's where things get a little bit more complicated. So the first thing I'm going to do, watching the live stream Josh posted. Josh got a live stream going on? That's fun. What's that about? I'm going to drag a bone out from the back end of the hand. So where the wrist is, I'm going to drag out a bone and I'm going to make sure that it's on a axis. So a perpendicular axis at that. Oh, gotcha. So if I drag this out on the x-axis here, I'm going to make sure it's perpendicular. So I've got these ones going on the y, and I've got this one coming out on the x. I'm going to clear the parent and disconnect the bone. Sorry, I'm going to clear the parent. So now it's totally separate. That's all good. It'll be in the recording anyway. So now I've got this bone that's totally separate, but it's still part of the same armature. Then I'm going to come to the elbow here, and I'm going to do the same thing. I'm going to drag one along the y-axis this time because it's perpendicular. I'm going to clear the parent, and I'm going to just drag it out, but making sure that it's still perpendicular exactly at a 90 degree. Then I'm going to introduce our little bend here. So I want my arm to bend this way, so I'm going to bring this back, and you'll notice now I have my arm doing that bend like I did on that first shape I was showing you. Cool. So now that we've got these two bones, let's name them as well. And hopefully naming them will help you understand what they do. So this bone here is called our IK hand target. And this is for the right side. And this one is called our IK pole target for the right side. So you have a hand target and a pole target. Now if I click on this bone here, I'm going to hit Shift I. Whoop, sorry. I'm going to go into pose mode and hit Shift I. You see a little window pops up that says Add IK. And I'm going to hit Without Targets. Another way to do it is to select our IK target and then the bone and hit Shift I, and it will say to active bone. And now you can see it's turned yellow. And yellow means that there's got an IK. So we saw that blue means it has a constraint, bluish green, and yellow means that it has IK. And now if we move our target, if it's orange, then that means it doesn't have a target. So if you added it without adding the target, it'll be orange. Yeah, so if you have it orange, then make sure you go target. So I'm going to select this armature, and our target bone is going to be our IK hand target, and it'll turn yellow. And then for our pole target, so we made our hand target and we made our pole target, let's select our pole target. There we go. And at first it's going to do some really wacky stuff because we have our IK is going infinitely. So here we have our length of our chain. So I don't know if you would have touched on it yet with Samantha, since it looks like you just briefly went over IK, but you have a chain of lines, right? A chain of bones. And your IK goes up and down that chain. So if you have it set to 0, it goes up the entire way. But we're going to set it to 2. So we only want our hand to affect everything from the shoulder down. We could make it 3 if we wanted to include the shoulder too, but personally I like to work the shoulder manually. It's really up to you though, and how you want to animate. But here you can see the shoulder rotates as well. So let's just leave it at 2. Now if I move our target bone, you can see the arm goes with it. Another thing you'll notice is that, yeah, it is 2, is that when we added our pull target, it flipped sideways. So now the arm is 90 degrees. So what we're going to do here is we have to go to our pull angle and just rotate it so that it's back in its original position. So it's usually 90 degrees. And this is, you'll have to do this like every time, and nobody knows why. It's just part of Blender. But now if we set it to 90 degrees, you can see we have our bend going the proper way again. So we have a bend going this way with our pull target perpendicularly facing outwards. Cool. So now everybody should be able to move their arm around like this. And the last step, now that we've added our pull target, is moving the pull target. So what the pull target does is change how our elbow is going to be aligned. So I can move my hand around, and I can use the pull target to change where the elbow is pointed. So how IK works is if this water bottle was my IK target, my hand is stuck to my IK target. And because of that, I can't move any of these bones. So like if I were to manually click on one of the bones and try and move them, it won't. Because of the way that it's following the algorithm. So in order to tell it where I want the elbow to be, we have to add another target, and that's what the pull target is. So that's what allows us to rotate the elbow around while still leaving the hand at the IK point. And this works for other things too. So hand, feet. If your creature has some kind of like sticky tongue, like a chameleon, you could use IK as well to have it wrap around things and animate it that way. So you don't always, like in that case, you probably wouldn't need a pull target. But in these cases, we do need a pull target. Greninja, I don't know if that would count. Maybe. The tongue doesn't really stick to things though, and it's also just wearing it as a scarf. But yeah, so that's pretty much it for today. I just wanted to show you guys how to get some basic stuff done with rigging. And then now I'll just touch on making a quick animation using the graph editor so that you can have something to submit with a rigged mesh. Oh, actually, sorry. One more thing. The reason I had you name all the bones that the way you did. If I come over here now and select my bones in edit mode, I'm going to select all of these bones. So everything with the R. Yep, underscore L time. I'm going to right click. And here, there's an option for symmetrize. Gavin's definitely going to teach you this in the lecture, but I'm going to teach you right now because it's really cool. I'm going to symmetrize. And now you'll see that based on my origin point, it's mirrored all my bones over. And if I click on them, so if I click on this bone, for example, you'll see this is clavicle L. So now I have clavicle R and clavicle L, which means that if I have this one here, it's forearm L, and this is IK pull target L. And if I click on this bone and go to its IK properties, you'll see that it's targeted to the left-hand target and the left pull target, and I didn't have to do anything. So now let's add a mirror modifier to our arm. Boom. Set the mirror object to our armature. Oh, and then one other thing, I don't know if I did this or not. Oh yeah, so these bones should not be deformed bones. Any IK bones should not deform, so check that off. But yeah, so now I have the left and the right arms. I have a root. I will apply the mirror modifier and then parent with automatic weights. And it did something weird, but it should still work, to be honest. It's probably gonna do something weird here, but yeah, it's just off center, but it's all right. And now you can see I control both arms. Why does it recognize R and L as symmetrical? It just does. But I'm not going to complain because it's incredibly convenient and I love it. So let me move my whoa. Yeah, hold on. Cursor. And, yeah, it is. It is that particular name. The only practical or the only like convention to the naming is you need some kind of non-alphanumeric character and then R or L on their own. So it has to be just R or just L. And then yeah, it doesn't matter if they're lowercase or uppercase. It's uppercase easier to see. How to symmetrize the mesh? I just used the mirror modifier. So I added a modifier for the mirror, and then I set the mirror object to the armature, so that way the mesh mirrors on the armature the exact same way. How to fish the mess with the armature when you added the armature to it? Oh, I guess that answered your question too. Cool. And I think now that I've applied the transforms, okay, almost. There we go. Now that I've applied all the transforms, it's going to work properly. But there's one more cool thing we can do because we named it left and right. So, like, yet another thing that comes from naming it. Let's pose this arm. So let's just put it back as if he's going to punch something. I don't know. And let's say I want this other arm to also be punching something. I can select these and copy. Then I can select these and Control Shift Paste, and it will flip. So I've now got it punching on both arms. So this is really good for, you're gonna have to do a walk cycle probably. And when you're doing the walk cycle, this is another random webcam thing I'm gonna do. But if you're doing the walk cycle, right, you're gonna have like this at some point, and rather than manually flipping it, what you can do is copy the one side and just paste it on the other side, and you can flip them that way. So that way you only have to do half the walk cycle and you get both. Well, all right. So yeah, so all of that is the reason why I had you guys naming them in that particular way. As you can see, the benefits that come from naming them properly very much outweighs the amount of time it takes to sit there and name them all. So definitely, definitely, definitely name your bones properly. True. And then here, to symmetrize the bones, just right click. Select the bones you want to symmetrize. So edit mode, select all the ones on the right or left, right click, symmetrize. Um, cool. Format for naming. Up to you, really. I mean, so for fingers, what I like to do rather than having I used to do this, but it takes so long, it's not worth it. But, you know, proximal phalange, and then the number of the phalange, and then medial phalange, distal phalange. But it's easier to just do pinky, pinky, pinky. And if you just type in pinky for all of them, followed by like pinky R or left or right, then it'll automatically rename the second one to pinky left or right 002 or 001 or 003. It'll just rename them all if you name them the same. Yeah, it'll just detect it. So here I can show you. If I This one's called Bone and this one's called Bone 01. If I rename this one to Pinky and this one to Pinky, it'll automatically make it Pinky 001. And then this one to Pinky and just Pinky 002. Three pinkies. Yeah, pretty much. Just the whole finger. And then yeah, so you don't need a number you don't need a number like this one, for example. There's only one clavicle on the left and one on the right, so there's no number. There'll never be a number. Same with upper arm, same with forearm, shoulder, all that. But if we hop over here, if you really put the time into it, so here I've got a whole bunch of custom meshes, and you can sort of tell what they all do just by looking at them, right? So this one encompasses the head, it probably does head stuff. These ones encompass the different parts of the torso. This is an example of using foot IK. So you can keep your character's feet on the ground. So this is a really good use of feet, like IK. Like if there was a box in front of my character, I could just put the foot on top of the box, and it would just be there. If you really want to get into like advanced rigging stuff, I have this here, which is like a foot roll controller, which is attached to another animation. So you can make animations and then control them with the mesh. So in this case, I've animated like the leg doing the foot moving, and then I can just control that in case I wanted to have the foot step up or whatever. And then same thing, pull targets, we talked about how they work. And then this hand I don't think has IK. No, there's no hand IK. Sometimes you want hand IK, sometimes you don't. It depends on the animator. In this case, when I built this rig for my animator, she didn't want hand IK, so we don't have it. It's up to your use. Yeah, so hopefully you guys learned about that kind of stuff. If you're still around and want to just quickly follow me diving into a little bit of animation, I'm going to model a door really quickly. Because Gavin said a door was fine for the submission. So just a really ugly, really quick door. Doorknob, sure. There, so now we have a door thing-ish. By the way, this part of the lab is all not planned, so we'll see how it goes. So there's a door, really basic, doesn't look too good, but it exists. That's the key part. And I'm going to add a new armature for it. It's a new single bone. And for a door, it's really simple. I'm just going to move this to the end of the door. I'm going to move this to this end of the door. And I'm going to parent it. Actually, I'm going to parent both of these with automatic weights. And now if I go to pose mode, then I hit this. There you go. The whole door moves. Cool. So now we have our rigged door ready to go. So now let's hop into the animation tab. Some people don't like this. Personally, I think it's fine. I do not mind animating in the animation tab. There is one complaint I have for it, is that it doesn't have the graph editor open by default. So you'll have to open that yourself. But if you've used Maya before, this will look a little bit more familiar to you, or even Unity. Unity's graph editor looks similar as well. Yeah, you can definitely do this for your lecture exercise. That's kind of why we're doing it. That's why we're using bones. So I'm animating the bone itself and not the object rotation for that reason. You could animate the object rotation, but yeah, for the assignment. It's just better for this to be on bones. I'll show you why. If we're using the graph editor and I want this to be on a bone, if I use different functions, I can get the door to smooth in and out. I can get the door to have smear frames. I can get the door to do all kinds of animation things that I can't do just by moving the object, or like just by changing the object's transform. So you could make animations that way, but you can't make good animations that way. So let's add one more window to this. I'm gonna add the timeline. So now we've got the timeline, our dope sheet, and our graph editor. Animations just kind of work better with bones. Yes, 100%. They allow you to do some really easy things. I'll show you how to make animations really quickly. Again, Gavin will show you this too. Kind of going a little bit farther than we should be today, since you'll be going over it in class, but anyway. Cool. So, Gavin showed you if you hit I, you can apply a bunch of things here. And it's going to bring up this giant menu, right? You guys know that? I assume. But you don't have to do it like that. Here, underneath keying, you have all of your available active keys. So in this case, I'm going to do location, rotation, and scale to my active keying. Now, if I hit I don't need to bring up that menu. I don't need to scroll through it till I find lock rot scale. I just hit I, and it automatically puts the lock rot scale in my timeline. So here we are. Now we have it in our timeline. So there's our base position. And now let's open the door. So I'm going to rotate it on the z-axis till it's that far open. Oops. First I have to move to the frame I want. So I'm doing keyframing. So we're doing this with keyframes. We don't have to worry about in-betweens as 3D animators. We only have to worry about keyframes, which is really nice, by the way. In-betweens, you'll have to tweak them a little bit, but for the most part, you can do entire animations between just using keyframes and editing the graph a little bit. Yeah, it's great. So let's say we want it to take 40 frames. So we'll move our door to our final position here and hit I. So now if I play back our animation, we have a linear transformation from our door from one location to another. And that's pretty much it. But now I'm going to use, sorry, I'm going to set our stuff to Euler. So Gavin was talking about how understanding quaternions is a total mess, and it is. It is nearly impossible. Gavin said he hasn't figured it out. I haven't even come close. I have no idea what I'm looking at. I don't know why two values changed when I only changed the z value. I just want it to be what I said. So there is a way to change it, and I don't remember exactly, so hopefully it doesn't take too long to figure out. Oh, there it is. So in the bone settings, change it to XYZ Euler angles. And the issue is I've already set these as not Euler angles, so I have to delete those actually, sorry. Let's try this again. Now it should give me Euler angles. There we go. Now we have Euler angles. So you will end up possibly running into some kind of gimbal lock. But I've never had that problem. And this way you have something that's a lot easier to work with. So let's try that again. There we go. Now we have the same thing, but this time we have it with Euler angles. In our graph editor now, if I zoom in here, you can see this blue line is our bone's Z rotation. So you can see it's rotating to -1, and that's our rotation. What we can do is take our timeline, or our dope sheet, sorry, and we can change our keyframe type and our interpolation mode. So in this case, I'm going to right click on the dope sheet with everything selected, and I'm changed the interpolation. Right now it's on linear, so it's just going to draw a straight line between my 2 points. But I want the door to have a smooth in and a smooth finish. So let's change it to Bezier. And you'll notice now here that all my straight lines in the graph editor have turned into Bezier curves. So if I click on this one, now I've got this smooth Bezier curve. If I play my animation back, it's hard to see. I'll have to adjust the curves a little bit. But let's move this in, change our handles. We have handles, oops, just like you would when you're mathing it out yourself. It won't let me click on this, which kind of sucks. Oh, there we go. And we can drag our Bezier handles out. And now if I play it back, whoops. Still kind of hard to see, but it's starting to smooth in and smooth out. You can't hide the rest of the lines, that is true. There we go. If you want to hide them all at once, you can just drag down. You don't have to like click each one, you can just drag. So if I drag all these like that. Yeah, so let's see if I can make this extremely sharp, just so we can get, so it's actually a little bit more visible. Actually, this should make it more visible. And the points at this point, now that we're using interpolation, no longer matter. So it's going to go up and it's going to go down. What you're supposed to be looking at is the graph line. So this is the current transformation of my value. So if I set it up, now my door is going to open past where it is right now and then come back. And if I play it, it will open or not. What are you doing? I think I missed something somewhere. Strange. What if I put it down here? Oh, wait. That would explain why nothing's happening. It's this one, isn't it? Nope. This one? Nope. Right. There we go. It's this one. Yeah, the graph thing is a lot to take in. That's why I wasn't really going to go over it. This is really ugly. I hate this. It's incredibly big. That makes 10 times more sense, though. It's not the Z. I used Z here, but relative to the bone, it's actually X. So it's not Z. I was using the wrong bone. Now we should be able to affect it. It's still scaled up incredibly large, but you can see how it's changing in real time. Let's smooth it out. So now you should see how it changes. There, so now it's really slow opening, and then it's never going to open all the way because I moved it all the way up here. But this works in terms of degrees, so -300 would be like down here somewhere. rotate like that. And now it's going really, really slowly before it opens. So yeah, that's just a really, really basic, unplanned intro to the graph editor and how to use it and stuff. You'd probably want this one to be a bigger window so you could use it more. You can also turn on this little button here. Oh yeah, that's pretty basic. They get pretty, for the quick free keyframing, I'm going to keying in my timeline. So I have to be in the timeline window, keying. And my active keying set, I'm setting to location rotation scale, which is what you'll be using 99% of the time. Another way to do it is to turn on that and then check this button, auto keying. And if you have auto keying turned on, every time you make a transformation, it will automatically drop that transformation into the editor and you can edit it. Or into the timeline, sorry. So now it's going to follow all those transformations that I just put in. Oh, I'm pressing I, so it's the same button. Just instead of bringing up that giant menu, it just looks here, goes, okay, that's your keying set, and then sets it. Yeah, so we'll look at the graph editor more and all of the crazy stuff. It gets kind of tricky, especially when like, oh wait, hold on. Ah, there we go. Yeah, so I checked off normalize, and now it's a lot easier to work with because the values aren't like in the hundreds. So there we go. Now we can change our rotation however we want. I don't want to get into too much depth or have any crazy looking animations going on. The other thing is when you have like, so you see this graph, right? And that's one single bone. So when you have hundreds of bones or a whole bunch of bones, the graph becomes a total mess. Yeah, that's not exactly a typical door. Let me open up the graph editor just for kicks. But like, it becomes a very big mess very quickly with all of these having their own transforms. I've hidden like 90% of them, but you can still see them in the action editor. Yeah, because every single bone that's involved gets added there. Yeah, it's a spooky door, right in time for Halloween. But just by adding the keyframes and hitting Bezier, like the door looks like it's moving around really smoothly, but all I did was change the interpolation type. So that's an easy trick. It's the only class where I can ask how many bones do you have in your door. The answer should always be one. Actually, that's not even true. You could have 2 bones in your door. If you wanted to animate the rotation of the door handle, you could very much have 2 bones in your door. Alright though. So hopefully you all have something that you can submit now for tonight's assignment. We touched on a lot of stuff today, not too in depth or anything. Next tutorial will be more of the same, but just more in depth. We'll get into some of the more crazy rigging stuff and like creating full-on rigs and how everything should be connected. But for now, that's all I have for you guys, so I'm going to stop the recording now.